Okay, this is the P2 paper from October 2023. It's question number 10, which is the last question on the paper. It's a really interesting question because look at what we've got. We've got a binomial expansion, we've got a geometric series, we've got geometric series again, but leading to a trig equation, which we're going to need to solve. So quite a different question, lots of different topics within it. Let's have a look at it and get started because it's quite long as well. So 10 part 1 part A says, finding ascending powers of x, the second, third and fifth terms of the binomial expansion of 3 plus 2x to the 6. Well, yeah, absolutely we can do that. So let's make a start. We have 3 plus 2x to the power of 6, and we're going to use the idea that a plus b to the n is equal to, and it's a to the n, it's nc1 a to the, right, take one off that power, add one onto the powers of b, nc2, take one off that power, add one onto the powers of b again, and continued and continued and continued. So doing that for 3 plus 2x to the 6 then, it's going to give us a to the power of n, so that's 3 to the power of 6, and then it's going to be 6c1, 3 to the 5, and one of our two x's, it's going to be 6c2, 3 to the 4, and a 2x squared, it's going to be 6c3, 3 to the 3, 2x cubed, and it's going to be 6c4, 3 squared, 2x to the power of 4. That's as far as I need to go. I'm just going to do a really quick check to make sure that all those terms are right. So if I look at the 3's, 3 to the 6, 3 to the 5, 3 to the 4, 3 to the 3, 3 to the 2. Yep, they're all following a pattern. If I look at my NCRs, I've got 6C1, 6C2, 6C3, 6C4. Yeah, happy with those. My 2x's, there aren't any. Then there's 2x, 2x squared, 2x cubed, 2x to the power 4. I don't really need to check this last bit, but I will do. That adds up to 6. 5 and 1 adds up to 6. 4 and 2. 3 and 3. 2 and 4. Yeah, I'm pretty happy that I haven't made any mistakes with any of that. So now we can actually go ahead and work out what that all works out to do. I'm just going to let you do that. That's 729. It's 2916x. It's 4860 x squared. We're not worried about the third term, and the fourth term is 2160 x to the 4. Trying to save myself as much time as possible. It's a long question. Don't do bits that we didn't need to do. And then what they've said is, in this particular expansion, the terms second, third, and fifth. Sorry, I was just looking up there. Second, third, and fifth terms. Those terms are in a geometric series. So this one, and this one will all be in a geometric series. So if I'm going to do that then, part B, we're saying that 2916x followed by 4860 x squared followed by 2160 x to the 4, we know that those ones are all going to be in a geometric series. So if they're in a geometric series, this divided by this is equal to r, and this divided by this is equal to r. So they're all equal to each other. Let's tell the examiner what I'm saying here. I'm saying that 4860 x squared over 2916x is the same as 2160 x to the 4 over 4860 x squared is equal to r. They're both equal to each other and they're equal to r. Well, it's more important that they're equal to each other, isn't it? So if I now tidy that all up, on the left-hand side, that's 5x over 3, and on the right-hand side, that's 4x squared over 9. So if you now just rearrange that, we get 4x squared over 9 minus 5x over 3 equals 0. Take x out as a factor. which leaves me 4x over 9 minus 5 over 3 equals 0. So we get x equals 0, which we're not interested in, or x equals, rearranging that actually comes to 15 over 4. So that's part B done as well. We've already done part A, the second, third and fifth terms. So we've done part B there. Yeah, good. Okay, moving on to part 2 then. So part 2 is like a brand new question here. It says we've got a different geometric series. This time we've got the first term, A is equal to sine squared. We've got the R is equal to 2 cos theta. We've got the sum to infinity is equal to that. And they want us to generate this equation. Well, actually, that's not too bad either. If we just do this then. So what are we saying? We're saying they said the first term was equal to sine squared. They said that the common ratio was equal to 2 cos. And they said the sum to infinity was equal to 8 over 5. And remember, the sum to infinity is A over 1 minus R, isn't it, when we're looking at it? So if that's true, A over 1 minus R is going to be sine squared theta over 1 minus 2 cos theta. That's going to be equal to 8 over 5. So all we now need to do is to try and sort this out in terms of, sorry, this is part A. Part A. We just want this to look like the equation we just did, but do it slowly. Don't try and rush to get there. So I'm going to say 5 sine squared theta is equal to 8 lots of 1 minus 2 cos theta. And then the sine squared, that's the one I'm going to change. I'm going to change that to 1 minus cos squared, aren't I? So I'm going to get 5 lots of 1 minus cos squared theta is equal to 8 minus 16 cos theta. Multiply that out, so 5 minus 5 cos squared theta is equal to 8 minus 16 cos theta. And then turn this into a quadratic in terms of cos. So we're going to get 5 cos squared theta minus 16 cos theta plus 3 equals 0. And if we go back, that's what we were trying to do for part A. And then part B says, right, can we find the exact value of the second term in the series? Well, yeah, first of all, let's solve the equation. So part B, solving the equation, if I've got 5 cos squared theta minus 16 cos theta plus 3 equals 0, it's almost certainly going to factorise. It does. It's 5 cos theta minus 1 cos theta minus 3. If you don't know how to factorise one of those, go and have a look at the other videos on my channel that show you exactly how to do that. I'm going to get here cos theta equals a fifth, or I'm going to get cos theta equals 3. Well, that doesn't work. There's no solutions from cos theta equals 3. So cos theta equals a fifth is what I want. Now, what am I trying to do? Well, we knew that R was equal to 2 cos theta. So R is equal to 2 fifths. And what did we know? We knew that A was equal to, what was A equal to? It was sine squared theta, wasn't it? Yeah, A is equal to sine squared theta. So just be careful with this now. If I want to get, this is a difficult question, but it's okay, it's the last question. If I want to get sine squared, remember that's 1 minus cos squared. Okay, so that's going to be 1 minus a fifth squared here. Well, that works out to be equal to 24 over 25. Okay, so we've now got our A and we've got our R, and the second term, quite a strange thing to ask for, but the second term is AR, isn't it, in our geometric sequence. So AR is just going to be equal to 24 over 25 multiplied by 2 over 5, and that works out to be 48 over 125 as that last part there. So we've finished off that one as well. Yeah, that's an interesting last question, a little bit unusual, but maybe watch the video more than once there, and hopefully that will all start to make sense.